Welcome back to class, everyone. Don't you feel like you're just here? You did really good on that last test, hopefully. But now we're on chapter 11. 16, 11. A little out of order, but now you're prepared to do your IB paper. So let's go. Properties of curves. So now we're going to go all the way back to when we did derivatives. We'll be reviewing some of that as we go. And what we're going to do is we're going to go over tangents, okay, normals, increasing or decreasing functions, stationary points, or in just a little bit of a review set. So pretty much when I do my calculus class, this is when we do graphing with derivatives. So the first thing we're going to do is these are the types of problems we're going to be able to solve and things to think about. This curve right here is y equals x cubed minus 4x, shown right here. Now what features of this curve would you describe to someone? How can you say some features of this curve? Think. All right. What you should have told me was maybe B is a maximum right here. D is a minimum because it's going up and down and up. It's where the slope of the curve changes. You could say as you're going to the left towards negative infinity, the graph decreases to negative infinity. As your x-axis goes towards infinity, your graph is increasing, y going to infinity as well. All right. You can also say maybe at points A, C, and E, that's where you have some x-intercepts. You could say C is the origin. That's also a y-intercept. All right, so just some things to think about. How can we use calculus to help to identify these important features? So you're going to actually be able to figure out these pieces with calculus. You're going to be able to figure out these little pieces, your intercepts with derivatives. And you're going to be able to figure out your end, it's called your end behavior with a little bit of calculus as well. All right? Now, in this chapter, and this is the whole chapter altogether, not just today, we're going to discuss how to use derivatives to find tangents and normals to curves, intervals where a function is increasing or decreasing. So for instance, it's increasing from here to B, then it decreases till you get to D, and then it increases off to infinity. We're going to find out where the turning points are, where you have your local minimum and maxima. Minima is where the point goes from decreasing to increasing. Maxima is where it goes from increasing to decreasing. So how to find points B and D. All right? Minima is just the plural, meaning more than one minimum. Maxima is the plural form of maximum, so more than one maximum. So we're going to be able to figure out what all these things are, how to find them, and utilize them to our best knowledge. All right, now, in order to do this, what we're going to do now is we're going to start with 11.A, which is tangents. So we're going to understand what a tangent to a curve is, be able to use the equation of a tangent to create equations of lines and curves, find the equations of actual tangents, all right, use technology, our calculators, to find tangential equations, and then finally find points where tangents intersect other geometric figures. All right, that reminds me, we're going to be needing our calculators. All right, so let's start off easy. A tangent to a curve at point A. What exactly is a tangent? A tangent is the best approximating straight line at curve A. So when you make a line at curve A, pretty much what you want to do is that's your tangent line. So you're going to approximate the straight line, and it's pretty much going to be what the graph is doing at that point. In cases where we have already seen, the tangent pretty much just touches the curve. Okay, so the tangent touches the curve at pretty much one point, and at that point it's what it's doing. So for instance, if I pick the point over here, the line would be going down, and as you move around it, it switches. Okay? Also, what you need to know is as you go around the circle, this is my tangent line, but depending on where I hit on the tangent line, on the circles, notice my tangent line will switch. So it's pretty much saying what the graph is doing, just with a straight line instead of a curve. For example, these two pieces, right here, it's touching the curve one place, right? That's why it's tangent line there, touching the curve there. All right, nice and easy. You guys know what tangents are because we've done it multiple times. Now let's move on to, however, for some functions, you need to know that the tangent may intersect the curve at the point of tangency. So it's possible for the tangent to pass through the curve at the point of tangency. So notice what happens here. If I was going to do my tangent line here, it would go like this and it wouldn't touch, but then when it gets to this point right here, it's actually going to go through the middle. And then what would happen is it would be increasing again. So it can actually pass through your curved line. That's allowed. A lot of people don't think you can pass through the curve. In fact, you can. Oh, it feels good to be teaching again. Consider a curve, y equals f of x. if A is a point with the x-coordinate A, so your x-coordinate right here is A, then the gradient of the tangent to this curve is f prime A. F prime A would be your derivative. Okay, so what that means is if you have a point here, your x-coordinate's A, this tangent line would be the derivative of the actual function. So since this is y is f of x is your curve, when I derive this curve, it's going to create a straight line, which is going to be my derivative. So your point of contact is a f of a. A f of a is otherwise known as what? Your x and your y coordinates. Okay, your x coordinate is a, your y coordinate is f of a. And the way to find f of a is you just take your x coordinate, you plug it in for x in the original equation, and then it spits out your y coordinate. So, knowing the statement, x equals a right there, we could figure out the equation of a tangent. It is y minus f of a equals the derivative f prime a times x minus a. Or simply f prime a, okay, if I take this, right, f prime a times x minus a, and I'm going to add f of a to both sides. I get the better equation, which is y equals f prime a times x minus a plus f of a. So pretty much what this represents is this right here, f prime a, and this is why I drove into school to do this. That's your gradient. This a is your actual x, and this f of a is your actual y. So if you have an equation xy from your point of contact, this is the x value of your point of contact, and this is your y value from your point of contact. All right, so you'll be finding the gradient, which is going to be a number. Okay, so this is your gradient, and what you're going to do is you're going to take the derivative, right, and you're also going to plug an x into that derivative. So when you do that, you're going to get a number, x minus a number plus a number. Right? That's not too terrible, is it? Whew. I'm going to do that on my TV. That's why I've come in. All right, so here's example one. You may be going, what the heck is he talking about? So find the equation of the tangent to f of x equals x squared plus 1 at the point where x actually equals 1. All right? Step 1. What we got here? We have to find our x and our y. So what is our x? 1. Our x and our y are the same as the what? Is the same as our, we just said it, our a and our f of a. So, in order to find f of a, we have to take x, which is 1, and plug it into where? The original equation. All right, so if I want to find out, how did I lose the marker already? There we go. F of a, right? So I want to find out f of 1, because that's what a is. A equals 1. So I'm going to plug 1 in for x. So 1 squared plus 1. 1 plus 1 is 2. So now I know something special. I know that the point of contact is my x value, which is 1, and my f of a, which is 2. So it's 1, 2. Right? Do you guys remember how to find the derivative? Uh-oh. We need to be using our power rule. Remember the power rule? The derivative of x to the n equals n times x to the n minus 1. So, an example of this would be, and I'm going to erase it real quick, say I wanted to find x to the 8th plus 7, okay? Derivative of this, my n would be 8, so it would be 8x to the 8 minus 1, which is 7. Plus, the derivative of any number that doesn't have a variable next to it, otherwise known as a constant, is just 0. All right, so the derivative of x to the 8th plus 7 would just be 8x to the 7th. Nothing to do with this problem, just to remember. So, find the derivative now of x squared plus 1. Should be done. Our n is 2. 2x, 2 minus 1 is 2x to the first, or 2x. right? If you need some extra help with this, I'll run through a bunch more of this stuff. Or you can just go review chapter 10. So at x equals 1, the tangent has a gradient of what? So I want to know what the gradient of this is. So I'm going to take the 1 and plug it in for the x of the derivative. That's how you find the actual gradient. So it'd be, my function is 2x, so it's 2 times 1. And 2 times 1 is 2. All right? So now I have a, I have f of a, and I have this. And what's this? This is a, this is f of a, and this is f prime a. So now I have the 3 pieces to plug into my equation. And remember the equation from the previous sign is f prime a equals x minus a plus f of a. So what I want you to do now is take these 3 pieces, boom, 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 plug them into that equation and give me an equation. All right, so f of a, 2, x minus 1 plus 2. Right? F of a, f prime a, x minus a plus f of a. All right, what do you think the next step is to simplify this? We're going to take this 2 and do what with it? Distribute it. 2x minus 2 plus 2. What's the next step? What is negative 2 plus 1? I mean negative 2 plus 2. 0. So my gradient line is y equals 2x. If you look at your graph, the graph f of x equals 2x. Okay, at point 1, 2, right here, here's point 1, 2. You have the tangent line. This tangent line is y equals 2x. Right? That's it. Isn't that easy? Pretty simple, right? What do you think? All right. 8 slides down. 33 to go. Now we're going to get into some fun. Here's the key. You can use a calculator to do this, and I'm going to go back to the calculator in a second. But I just want to show you how to actually find this stuff on equation. Now the calculator will give you the actual equation, so you don't have to do all that work, and we'll use this sometimes, but I'm going to try to steer clear of it a little bit. Now the way you do this on the calculator is the first thing, and I messed this up the first time I made this thing. You want to find the equation of the tangent where x equals 1. First draw the graph y equals x squared plus 1. So step 1 is you're going to press y equals and enter x squared plus 1 into your calculator. So on my calculator, oh, I like doing this so much better than at my house. I wrecking my back. Got my calculator here. I press y equals. Y equals. Right in here, I'm going to press x squared. X is x squared. What is it? Plus 1. All right. I'm going to hit that, hit enter, and then the graph button's right here. Boom. So I got my graph. Now, if you look at my graph, it looks pretty ugly. So I'm just go to the window. I want to make it a little bit better. I'm just going to go negative 10. Let's go max 10. Scale 2. It doesn't. You just try to estimate. Y minimum negative, I don't know, 10. Y maximum 20. All right, scale 2. I'm just going to estimate. See what that. Oh, this looks pretty good. All right, I got a graph. I'm happy with that. So now I got my graph. With the graph on the screen, keep this graph here. You're going to now type in your calculator. Second program, which is the draw button. And then you're going to go to number 5, tangent, from the draw menu. So, from right here, what you're going to hit is, you're going to hit the second, the light blue button, program button, which is right here. You're on this menu. So under draw, you go down to number 5, which is tangent. Hit enter. Okay? Now, I'm going to hit the number 1 because I want to know when x is 1. Now, why am I hitting x equals 1? The reason this says is at the point where x equals 1. If this was 6, I'd type in a 6. If it's negative 2, I'd type in a negative 2. But as you can see right down here, I typed in the 1 because it says x equals 1. I hit enter. Watch what happens. It draws that nice graph for me. Not only does it draw the graph, but it gives me the tangent line. Right here it says y equals 2x plus 0. So that's my tangent line. So I go back to here. And what happens to happen? What happens to happen is this tells me that, based on this information right here, my y equals 2x. So the steps you're going to take are y, you enter the equation, whatever the equation is, second program, go down to 5-bit draw, and then enter whatever x value is. And that's how you find it. And it doesn't matter what your y value is, because it can compute that automatically. So that's how to use your calculator. All right, we're going to do 11.A and see how you do. I'm going to guide you through the first one. As soon as I get a cup of water, we'll move on. All right. So the graph of f of x equals x squared minus 4x is shown. That's this purple graph. All right. We're going to find f prime x first. So you guys are more than capable of deriving that. So derive it. And you're going to use, right down there, your special equation to derive it. Now what equation is that? That is, once again, the power rule. All right, so you have two functions there, x squared and minus 4x, so you derive them individually. Derivative of x squared is 2x, the derivative of minus 4x is minus 4. So the derivative of x squared minus 4 is 2x to the first, or just 2x minus 4. Anytime you derive x, it automatically becomes 1. All right, hence, find the equation of the illustrated tangent. So do you think this tangent right here is this equation? It's not. You know how I know it's not? Because it's going down. So that wouldn't be a 2x, it was going down. So first thing you need to know is the point of contact. Do you know what the point of contact is? Given right there. 1, 3. All right, so that's good. So now that we find the point of contact, we have two things. We have our A and we have our f of A. So what do we need to find? We need to find f prime A, which we don't know what that is yet. So how do we do that? We take our f prime and we plug in 1. So you're going to find f prime is 1, because this is our f prime A. 2 times 1 minus 4, 2 minus 4 is negative 2. And this is my f prime A. Now what are we going to use these three things for? We're going to plug them into our equation. What equation do we plug them into? The tangent line equation up here. Y equals f prime x. Y equals f prime A, x minus a plus f of a. So take, boom, 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 plug them into the equation, simplify the equation, and solve. Ooh, get my steps in doing this. Let's see, I'm at 2,400. Let's see how many steps I can get doing one lesson. All right, so the equation, f prime a, negative 2, times x minus 1 plus negative 3. All right, so there's two things you have to do here. The first thing you're going to want to do here is what with this negative 2? Distribute it. Negative 2x plus 2 minus 3. Now what? 2 minus 3. So y equals negative 2x minus 1. And that, my friends, you're my friends, right? Here's your answer. Any questions to them? Good. Go to number. Boop. Boop. Notice I didn't need the calculator. I'm not going to cheat with that calculator. Let's go to number 2. What I want you guys to do now is find the equation of the tangent of A and B. There's a lot more to do. We're just going to start with A and B. Problem 2 actually has A, B, C, D, E, F, G, H, I, and J, K, and L. Ooh, there's a lot here. All right. Y equals x squared at x equals 4. When x equals 4, what does y equal? You always have to find that out. Plug 4 in. 4 squared is 16. So my contact point, or my point of contact, is xy, 4, 16. Step 1, always find your contact point. So step 1 is find your contact point. Step 2, derive. Derivative of x squared is 2x. dy dx or y prime. Step 3, we have our, I'm not going to do this forever, but we have our A, we have our f of A. So step 1, find A and f of A. Step 2, oh, that is step 2. Step 3, derive. Step 4, find f prime A. So this is f prime. F prime A would be, plug 4 in there. So when x equals 4, 2 times 4 equals 8. All right, and my 8 right here would be my f prime A. Take those 3 things, plug them into the equation. Right? So the tangent equation is y equals 8 x minus 4 plus 16. Distribute the 8. 8x minus 32 plus 16. Negative 32 plus 16 is a minus 16. So y equals 8x minus 16. Yes! All right, let's go to B. Same steps. Step 1. I'm going to assume you guys pause this and we run again. When x equals negative 2, y equals negative 2 cubed. Negative 2 cubed is negative 2 times negative 2, which is 4, times negative 2 is negative 8. My point of contact then is A, f of A, negative 2, negative 8. All right? Derive. Derivative of x cubed, 3x squared. 3 minus 2, 3 minus 1 is 2. We've got to find f prime A. So at, what's x? At x equals negative 2, plug that in for x. 3 times negative 2 squared. Negative 2 squared is 4. 4 times 3 is 12. All right, my 12 is my f prime A. Boom, boom, boom. Plug them into the equation. Assume you're done. So you got 12 times x minus negative 2 plus negative 8. All right, now here's the key. Don't distribute your negative 12 yet. Look at this. X minus a negative 2. That's the same as x plus 2. So it's y equals 12 times x plus 2. And then you can just write that as minus 8. All right, after you do that, distribute your 12. Y equals 12x plus 24 minus 8. 24 minus 8. 12x plus 16. All right. That's A and B. C and D. All right. Problem C. Y equals 3 x to the negative 1, negative 2. Same steps. When x is negative 1. So this is the same as y equals 3 over x. If you want to rewrite it, you can. You have to know. So I want to find out what y is. So when x is negative 1, y is 3 divided by negative 1, which is negative 3. My point of contact, negative 1, negative 3. So right here I got my A, and right here I got my f of A. Derive. 3 times negative 1 x, negative 1 minus 1 is x to the negative 2. Okay, you're just using your power rule. When x is negative 1, now this is the same as negative 3 divided by x squared. Because remember, x to the negative a is 1 over x to the a. Okay, so 3x to the negative a would just be 3 over x to the a. The negative sign stays. Showing x equals negative 1, I plugged it in here. So f prime of a would be negative 3 times negative 1 squared. Negative 1 squared is 1. So you got a negative still. 3 divided by a positive 1 is just negative 3. So my negative 3 is my f prime a. Plug it into the equation. You get negative 3 times x minus negative 1, close parentheses, plus negative 3. Okay? Once again, right here, double negative, so this becomes negative 3 times x plus 1 minus 3. Going to distribute my 3. Negative 3x minus 3 minus 3. And then you're going to combine like terms right here. Negative 3 minus 3 is negative 6, so it's y equals negative 3 minus 6. All right. D. When x is 2. Put my 2 in there. Just so you know, when we convert this later, we derive this later, y equals 4x to the negative 3. You can run back and forth with it, doesn't matter. When x equals 2, y equals 4 over 2 cubed. 2 cubed is 2 times 2 is 4 times 2 is 8. 4 over 8 reduces to 1/2. Point of contact, therefore, is a is 2, f of a, a little higher, is 1/2. All right? Derivative. I like to derive this one because it's easier because you don't want to derive a fraction. We don't know the quotient rule yet. So 4, negative 3, minus 1 is negative 4. So it's 4 times, the derivative of this is 4 times negative 3, x to the negative 4. 4 times negative 3 is negative 12, x to the negative 4. In order to find f prime a, we're going to take our x, or our a, which is 2, negative 2, 12 over x to the 4th, because this is to a negative exponent. You can move it to the bottom. You put the 2 there, not the 1/2. So at x equals 2, negative 12 over 2 to the 4th. 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's negative 12 over 16. I can divide both of these by 4, negative 3 fourths, which is my prime a. All right? Plug them in. Y equals negative 3/4 x minus 2 plus, distribute the negative 3/4. Negative 3/4 x minus is a plus 6 over 4. Now, negative 3/4 times 2, or 2 over 1, is negative 6 over 4. That reduces to negative 3/2. And that reduces to positive. Because this is a negative, sorry, this is a negative. So it becomes positive, negative, and negative is a positive 6 over 4, which is positive 3/2. Plus 1/2, 3/2, plus 1/2 is 4/2, which is 2. Negative 3/4 x plus 2. Right? It takes longer than I thought. Right. Next one. E and F. E. Take the 1. Look at that. So when x equals 1, y equals 1 squared plus 5 times 1 minus 4. Right? So 1 plus 5 minus 4. 6 minus 4 is 2. Right. Next, point of contact is 1, 2. Once again, this is my A. This is my f of a. I got to find f prime a. So the derivative of y prime is the same as f prime a. So what you do is you're going to derive that and you get 2x plus 5. 2x plus 5 plus 0, 2x plus 5. Right? You're going to take your a. Look at it. 2 times 1, so at x equals 1, 2 times 1 plus 5 is 2 plus 5, which is 7. My 7 is my f prime a. Type them into the equation. So the tangent line has the equation. 7 times x minus 1 plus 2. 7x minus 7 plus 2 Negative 7 plus 2 is 7x minus 5. Okay. Getting better at these? Hope so. When x equals negative 2, plug it in there to find out what y is. So y equals 2 times negative 2 squared plus 5 times negative 2 plus 3. 2, this is 4 times 4. 2 times 4 is 8 plus, this is minus 10 plus 3. 8 minus 10 plus 3. Oh, I already had it there. 8 minus 10 plus 3. Negative 2 minus 3 is negative. Wait. Negative 2, 8 minus 10, oh, plus 3. Negative 2 plus 3 is 1. Oh, made my first mistake. All right, so my point of contact, therefore, is 2, 1. A, f of a. Derive it. When you derive, 2 times 2x is 4x plus 5. We're going to plug our a in there. So when x is negative 2, 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. Negative 3 is my prime a. Boom, boom, boom. Plug them in. Negative 3 times x minus negative 2 plus 1. Minus negative 2 becomes negative 3 times x plus 2 plus 1. You don't add these together yet until you distribute the negative 3. Negative 3x minus 6 plus 1. Negative 3x minus 5. All right? Pretty easy? I think so. G and H. Got 6 more of this. All right, ready? When x equals 0, y equals 0 cubed plus 2 times 0, 0. Point of contact, therefore, is 0, 0. In this case, my a and my f of a are both 0. That's okay. Derive this, 3x squared plus 2 times 1, which is 2. F prime a, you plug in your 0. So at x equals 0, 3 times 0 squared, which is 0, plus 2 is 2. So 2 is my f prime a. All right? So, tangent equation, 2 times x minus 0 plus 0. X minus 0 is just x, so this is just 2 times x plus 0. 2x plus 0 is 2x. Yes, that was a quick, easy one. Oh, this one's a tough one. What's our first step? First step is to rewrite this. I'm going to do this twice. This is the same as x squared over x plus 4 over x. X squared over x is x plus 4 over x to the first power. So it's 4x to the negative 1. So when you rewrite it, that's why you rewrite it. Now, we don't need it rewritten yet, but when we derive it, that's when we're going to need it rewritten. I always rewrite it right off the bat. This is my personal preference. You can do it whenever you want. But in order to find out what y is, you can just take this negative 1 and plug it in for both these x's. So when y is negative 1 squared plus 4 divided by negative 1. Negative 1 squared is 1. 1 plus 4 is 5. 5 divided by negative 1 is negative 5. All right? Point of contact, therefore, is negative 1, negative 5. All right? Step. So my a is negative 1. My f of a is negative 5. Derive. This is what I'm deriving. This is why I did this. Derivative of x is 1. Derivative of 4x to the negative 1 is 4 times negative 1 x to the negative 2. So that's negative 4x to the negative 2. Obviously, you can rewrite this because this is x to the negative. You can put that in the denominator. and it's 1 minus 4 over x squared. Why would I do that? Well, I want to find f prime of a. So I'm going to plug in a negative 1 in for x squared, a negative 1. 1 minus 4, negative 1 squared. Negative 1 squared is 1. So it's 1 minus 4 divided by 1. 1 minus 4, which is negative 3. And that is my f prime a. Got it? Pretty simple. We're going to plug a, b, and c into there. So y equals negative 3 times x minus negative 1 plus negative 5. Minus a negative 1, negative 3 times x plus 1. Minus 5. Distribute the negative 3. Negative 3x minus 3 minus 5. Negative 3x minus 8. Okay. C, F, G, H, I, and J. All right, you can always use the technology to check your answer as well. I'm not going over that though because it'll take forever. First thing, when x is 2, plug in 2. 2 minus 2 times 2 squared. Wait a second. Uh-oh. Did I do this one wrong? Oh, no. All right, so I think it's when x equals 0 now. Oh no, I forgot where all my books are. So, first hiccup of the day goes right there. I don't got any IB books laying around. So, if x is 2, I obviously want to plug in a 0. I think x is supposed to be 0. But I gotta just check real quick. 2i, because all this does come from your book, and I want to make sure it stays consistent with your book. What numbers is 2i? 2i, when x equals 2. Oh man, I'm about to redo this whole problem. Alright, so y equals x minus, alright, well, when x equals 2, whole answer is going to change. So, pay attention to how I do this. I'm going to do this off the gut. So this is going to be 2 minus 2 squared. So 2 minus 2 times 2 squared would be 2 plus 3 is 5. 5 minus 2 times 2 squared is 8, which would be negative 3. Oh, it's a negative 3. All right, so x equals negative 3. All right, next. Our point of contact, everything else should be right, is 2, negative 3. Wow, it's amazing how that worked out. All right. All right, so now we go to the next one. Sorry, I'm just fixing this on my problem right here. All right, all fixed. So, take the derivative of this, you get 1 minus 4x. You're going to take f prime, you're going to type in your 2. 1 minus 4 times 2, which is 1 minus 8, which is negative 7. Okay, so in this case, this is my a, this is my f of a, and this is my f prime a. Those three all go in there. So you got negative 7 times x minus 2 plus the negative 3. Distribute the negative 7. Negative 7x plus 14 minus 3. 14 minus 3 is negative 7x plus 11. All right. J. 1, you're going to plug in 1 cubed minus 5 times 1. 1 minus 5 is negative 4. So my point of contact is 1, negative 4. 1 is my A. Negative 4 is my F of A. Derive this. 3x squared minus 5. Okay. 3 minus 1. F prime A, you're going to plug your 1 in. So when x equals 1, 3 times 1 squared is 3. Minus 5 is negative 2. F prime A. Type them in here. Y equals negative 2. X minus 1 plus a negative 4. Negative 2x plus 2 minus 4. Y equals negative 2x minus 2. Okay. There's 2 of this variety. Y equals 3x minus 1 over x squared at negative 1, negative 4. So, you can rewrite this as y equals 3x to the negative 1, because technically this is x to the first. 1 over x squared just becomes x to the negative 2. We're going to use this later when we derive it. All right? So I'm going to actually derive it right away, because you know why? Because this is my a, this is my f of a. There's no reason to plug this into this equation, because if I plugged 1 into here, guess what I would get as an answer? I would get negative 4 as an answer. Okay? Because it would be negative 3 minus 1, which is negative 4. Derive that, you get negative 3x to the negative 2 plus 2x to the negative 3. I want to rewrite this because this is a negative exponent, goes on bottom. Negative exponent goes on bottom, so you get negative 3 over x squared plus 2 over x cubed. We're going to plug in our a into there. So at negative 1, negative 4, negative 3 over negative 1 squared, which is 1, plus 2 over negative 1 cubed, which is negative 1. So this becomes positive 1, so negative 3. This becomes a negative minus 2. 3 minus 2 is 1. A negative 3 minus 2 is negative 5. And this is my f prime A. I take my A, I take my f of A, and I take my f prime A, plug them all in. Negative 5 times x minus a negative 1 plus negative 4. Negative 5 times x plus 1 minus 4. Negative 5x minus 5 minus 4. Sorry, minus 4, I should have said before. Negative 5x minus 9. Right? All right. Whew. Feeling it. All right. Only given this, so we do have to find the y. So the first step is to plug negative 1 in for x. 3 times negative 1 squared is 3 times 1. 1 divided by negative 1 is negative 1, so a negative negative 1 would be plus 1. So this would be 3 plus 1, which is 4. Our point of contact, therefore, is 1, negative 4. Okay? Now, I could also rewrite this equation. The way I'm going to rewrite this equation to derive it is 3x squared minus x to the negative 1. And I could derive that. My point of contact is negative 1, which is my a, and 4, which is my f of a. Right? Derivative of this. 3 times 2x is 6x minus negative 1 to the negative 2 minus a negative is a plus. So it's 6x plus x to the negative 2. Because this is like this, in order to make this a positive, I'm going to put a 1 over it. 6 plus 1 over x squared. I'm going to plug in negative 1 for x. So when x equals negative 1, I go with a 6 times negative 1 over plus 1 over negative 1 squared. This becomes a negative 6. This becomes 1 over 1. Negative 6 plus 1 is negative negative 5. And negative 5 is my f prime. All right. Type 3 into the equation. Negative 5 times x minus a negative 1 plus 4. Negative 5 times x plus 1 plus 4. Negative 5x minus 5 plus 4. Negative 5x minus 1. Right? Not too terrible yet, right? About halfway there. All right, that's it. Problem 3. Find f prime x. All right? Derive it. You're going to derive that using your power rule that we've been using before. Pretty simple. All right. Way you do that is, the derivative is what? What's the derivative? Negative 2x plus 6. Right? Hence, find the value where f prime x equals 0. So now you're going to set that equal to 0, and you're going to solve. I'm trying to get some of this stuff off the board. So when you do this, it should be done. Set f prime x, set this, which is your f prime x, equal to 0. Subtract 6 from both sides. Negative 2x equals negative 6. And then you do what? Minus 6. Divide both sides by negative 2. Negative 6 divided by negative 2 is x equals 3. That's it. Pretty easy. C. Explain the geometric significance of the point where f of x equals 0. Well, what happens at this point? What is this line, x equals 3? X equals 3 is a blank line. You should have said horizontal line. X equals anything is horizontal. That's going to play a big role in what we're going to do in the future. Right? Next, the tangent y equals 2x cubed plus kx squared minus 3, and the point where x equals 2 has a gradient of 4. Well, that's interesting. Find k. Find k. So you guys are doing this time. I'll give you a hint. First thing you're going to do is derive the equation. When you see the word gradient, you're going to derive. All right, so the derivative of this is going to be 2 times 3x squared, which is 6x squared. This is going to be k times 2x, which is 2kx. Okay, so when I derive this, so y prime equals 2 times 3x squared, that's where I get the 6x squared from, plus k is just a constant, times 2x, that's where I get 2kx, and then minus the derivative of 3 is 0. Okay, so that's how you do that part. Next, well, what does this say? When x is 2, it has a gradient of 4. So the gradient is the actual answer, right? So what can I do with this 2 and the 4? What's my gradient? This is my gradient. All right? So when x is 2 and dy dx equals 4, solve for k. Go. You're going to plug and solve. All right, should have enough time. 6 times 2 squared plus 2k times 2 equals 4. Right? 2 squared is 4. 6 times 4 plus 2 times 2 is 4. K equals 4. 6 times 4, 24. So it's 4k equals 4. What do we do to both sides to solve for this? Subtract 24. 4 minus 24 is negative 20. Now what do? Divide both sides by 4. K equals negative 20 divided by 4 is negative 5. Right. That's part A. Part B looks like it's a little longer, right? Find the tangent to the equation. That's just what we did for those previous, 12, 16 problems. So since K is negative 5, rewrite this equation where K is negative 5. Right? Y equals 2x cubed minus 5x squared minus 3. So now what you should be able to do is, x is still 2, right? What else do we got? Our gradient is 4. All right, so we got that information. So we got our A. We got our F prime A. What are we missing? We're missing our F of A. So what you're going to do now is you're going to find F of A. All right, so when x is 2, you plug it into this equation. 2 times 2 cubed minus 5 times 2 squared plus that gives you 2 times 8, which is 16, minus 5 times 4, which is minus 20, minus 3. 2 times 8 is 16. Negative 5 times 4 is minus 20, minus 3. 16 minus 20 is negative 4. Negative 4 minus 3 is negative 7. And my negative 7 is my F prime. Okay. Take this. Oh, sorry, that's my F of A. And plug them into our equation. So our point right here is our A, F of A, F prime. Plug them in and solve. So the tangent to the equation is what? 4 times x minus 2 plus negative 7. 4x minus 8 minus 7, 4x minus 15. Look at that highly difficult looking problem that you guys are just able to solve. And you did it fairly simply. Ready to go easy again? Yeah, easy, easy. All right. I'm just looking for my rag. All right, hopefully I can pick this up. Number 5. Which equation of another tangent to y equals 1 minus 3x plus 12x squared minus 8x cubed, which is parallel to the tangent at 1, 2. All right, find the equation. All right, when this works, first thing you do is derive it. Derivative of 1 is 0. Derivative of negative 3x is negative 3 times 1, which is negative 3. Derivative of this is 12 times 2x, 24x, and the derivative of this is minus 8 times 3x squared. So that's minus 24x squared. All right, and the derivative of 1 was 0. Now parallel. What is parallel? Parallel means the gradient's going to be the what? Same. So we have to first find the gradient of this equation, and then once we find the gradient of this equation, we can find the one of the parallel arm. So what do we know about this? We have an A of 1 and F of A of 2. So how do we find the gradient? The gradient is F prime A. We're going to plug in what into this equation? 1. Negative 3 plus 24 times 1. Negative 3 plus 24. Minus 24. Negative 3. Whoa! Negative 3. There are too many buttons there. All right. Now, so can we find the tangent line at 1, 2? Of course we can, because this is F prime A. So So now we're going to find the tangent line of 1, 2 at negative 3. So what equation are we using to do that? The one we've been using. We're going to use the one that is y equals f prime a x minus a plus f of a. I got my thing's all messed up, my order. So do that. You get negative 3 is my gradient, right? And the equation, negative 3 plus 24x minus 24x squared equals negative 3. If I plugged 1 in here, I get negative 3, right? And I know that's true. But what can I do? I can also solve for what letter here? I can solve for x, right? Oh, we messed up. You don't need this equation. So because I set this up like this, my answer is negative 3, right? There could be a different answer, though. How do I find the different answer? What could I do with negative 3? I gotta move the negative 3 to the other side. Negative 3, if I add 3 to both sides, what happens? They cancel out. 24x minus 24x squared equals 0. What can I do here now to solve for x? Because I got my equation, I got my gradient. I could take out a and x. So I can actually take out a 24x. 24x divided by 24x squared leaves me with an x, right? Wait a second. This should say 1 minus x. I got that backwards. All right, so I got 24x and 1 minus x equals 0. I set 24x equal to 0. X equals 0. And I set 1 minus x. It doesn't matter which way it is. 1 minus x equals 0. So x equals two things. It equals 0, or if I add x to both sides, it equals 1. All right? I'm just adjusting this on the PowerPoint I'm going to give you guys. All right, so what do we do next? Which one of these is going to be good? Well, we already know that x equals what? We already know x equals 1, so we don't care about that. X also equals 0. Okay? So since x also equals 0, we have the other x value for where the curved gradient is negative 3. We already knew about the 1. How do we know about the 1? It's that one right there, right? So that one's all good. But we care about the 0. So what do we have to do with that number? We're going to take that 0 when x equals 0 and we're going to plug it in where? This equation. Now watch what happens. When we plug this 0, not into this equation, sorry. This is my a. This is my f prime a. Now watch what happens. This, if I plug 0 into this equation, negative 3 plus 0 minus 0 is negative 3. So we already know that. So we don't have to plug it in. But we do have to plug it into the original equation. Because we have a, we want to know what f of a is. This is what we don't know. So we plug it in here. 1 minus 3 times 0 is 0, minus 0. So this becomes y equals 1. All right? So the point, y equals 1. We have 1. So the tangent to the curve 0, 1 is parallel to the tangent at 1, 2. Okay? Because since y is 1, the equation here would be 0. Right? If I want to continue on with this, I could type in my negative 3, which is my f prime a, x minus a, plus 1, negative 3 times x plus 1. And that's the actual curve. Okay? Because this is my a, This is my f of a, and my f prime a from previous parts of the problem is negative 3. That's probably the most difficult problem here. And then it gets a little easier. All right. Whew. I didn't like that one. 1 bit. But we'll keep on going. All right. What do I got going on here? Anything moving here? All right, 6. Consider the curve. Another problem that you probably won't test on, but it's good to know. X squared plus a and x plus b. Put a and b are constants. Find the tangent to this curve at a point where x equals 1 and where 2x plus y equals 6. And then I want you guys to find the values of a and b. So you're going to start with that. Ultra. The first thing, y equals negative 2x plus 6. All I did here was I rewrote the equation. I pretty much subtracted 2x for both sides and got y equals negative 2x plus 6. Now this is a terrible marker. Okay, I'm sure. So the next step is, what does my tangent have a gradient of? The gradient is the slope. What's my gradient? Thing before the x. Gradient is negative 2. So now I know my tangent has a gradient of negative 2. What else do I know? When x equals, so now I have my f prime a, and my a, what do I need? My f of a. So when x equals 1, how do I find my f of a? Plug that into original equation. Y equals negative 2, not the original, the derivative, times, the original, times 1 plus 6. 6 minus 2 is 4. So this is my f of a. So I got f of a, I got a, and I got f prime a. All right? I got my point of contact, a, f of a. So obviously, since we have all these three things, we have our original equation, y equals x squared plus ax plus b, right? What do I have to do that original equation now? What do you think? Derive it. 2x plus a, and the b cancels out. So it's 2x plus a. These are just constants, so that's why derivative of constants here. So we have our next part. When x equals 1, our gradient's negative 2, right? When x equals 1, our gradient's negative 2. We can use that information to solve for a now, and now that's what I want you to do. All right. 2 times 1 plus a equals negative 2. 2 plus a equals negative 2, and a equals negative 4. Because what you're doing here is you're subtracting 2 from both sides. We got a. All right, let's rewrite our equation. So we got a equals negative 4 and y equals 4. Why does y equal 4? That's our y. So since those two things are true, here's our equation. Y equals x squared plus ax plus b. We got y, right? What's y? Because this is technically our xy. Y is 4, right? So 4 equals 1 squared plus negative 4 times 1 plus b. 1 minus 4. 4 equals negative 3 plus b. Add 3 to both sides. And b is 7. That's it. That wasn't too hard, was it? It's like a maze where you have to work your way through the maze and figure out the correct way to do the path. All right, we're going to do 7 and 8. And then all the next examples are a lot of calculator work, so it's pretty easy. So let's go, keep moving. Problem 7. I think we can get this. I gotta get this done by, we got a half hour. Consider the function f of x equals x squared plus 4 over x squared. Find f prime x. Want to rewrite this? All right, so you should have rewrote it. Then we're going to use our power rule. F of x equals x squared plus 4x to the negative 2, because this is on bottom, that's why it's a negative exponent. Derive that, you got 2x plus 4 times negative 2, x to the negative 3, right? Because this is just 4 times negative 2, x to the negative 3, negative 8, x to the negative 3, 2x. All right? And then you can rewrite this back in this form, because this is a negative power, 2 over negative 8 over x cubed. Right. Find the values of x at which the tangent curve is horizontal. Okay, so we're going to keep on moving through. So, how do we know when it's horizontal? Horizontal tangents. What's the slope of a horizontal line? 0. So horizontal tangents have a gradient of 0. All right. Gradient of 0. So we're going to set 2x minus 8 over x cubed, set it equal to 0. And now you solve for x. Now, in order to solve for x, what would the first thing you think you would do would be? How can I do this? What can I multiply this by so that I can put these in the same equation? X cubed over x cubed, which equals 1. So technically 2x over here, you do x cubed times 2x, which is 2x to the 4th, because x to the a times x to the b equals x to the a plus b. So that's x to the 4th over x cubed minus 8 over x cubed. Because these are both over x cubes, I can just say 2x to the 4th minus 8 all over x cubed. That's allowed. Now, I want to set this equal to 0. Since I want to set this equal to 0, what has to be 0, the top or the bottom? Well, if the bottom is 0, my answer is undefined. So I can get rid of this. How do I get rid of this x cubed? Multiply both sides by x cubed over 1. That cancels out. 0 times x cubed over 1 is 0. So you're left with 2x to the 4th minus 8 equals 0. Come on, let's use your algebra. Next step, you're going to add an 8 to both sides. 2x to the 4th equals 8. What do we do next? Solve for x. Divide both sides by 2. X to the 4th equals 4. Now what? X equals plus or minus square root of 2. All right, the reason for this is if I take the square root of both of these, I end up with x squared equals 2. Therefore, x equals plus or minus square root of 2. All right, it's just a tricky way to do it. If you just put x equals plus or minus the 4th root of 4, that's also okay. All right. Finish this problem up. You're not going to like this though. You need to have this as plus or minus square root of 2 to do the next part, because now there's going to be a bunch of radicals. Okay, so C. Consider the function f of x equals x squared plus 4 over x to the squared, x squared. Show that the tangent lines are the same line. So now what you're going to do is you're going to use the information from the previous slide to show that the tangent lines are the same slide. So for instance, when x equals the square root of 2, f of the square root of 2 equals what? So use that equation and find out what f of the square root of 2 equals, as I just clean this board a little better. All right, so you type square root of 2 into that equation, and you're given the square root of 2 squared over 4 plus the square root of 2, which is 1.41 something, but we leave it as square root of 2 because look how nice this is going to come. The reason we leave this as square root of 2 is very simple. If I have the square root of x, let me just put this here. Square root of x squared, that just equals x. So the square root of 2 squared equals 2. Square root of 2 squared is 2. 4 divided by 2. 4 divided by 2 is 2. So 2 plus 2 is 4. That comes out pretty nice, doesn't it? So when x equals square root of 2, f of x equals 4. Now the horizontal tangent at square root of 2, 4, is y equals 4. Okay, because this is my x value, and this is my y value. Right? And we said it was 4 from the previous problem. Y equals 4, sorry. Because y equals 4, this is your horizontal line. Alright? And we said it has to be a horizontal line. Now do it with negative square root 2. Alright? Negative square root 2. Squared is still 2. 4 divided by negative square root 2 squared is still 2. 2 plus 2 is also 4. Alright, so once again, this is my x. This is my y. Since it's a horizontal line, it's y equals 4, because that's a horizontal line. And whatever the y is, that's what your horizontal line is. Because if the y is that for one thing, it's that for everything else. Therefore, the tangents have the same line, and that same line is y equals 4. Right? This is going to take a week to do. All right. 7. Now let's go to 8. Consider the curve. Y equals x squared plus 1. All right. In this curve, first thing I want you to do is find f prime x. All right. Should be done. Remember, you're using the power rule. You get 2x is your answer. Okay. Next thing you're going to do is find the equation of the curve when x equals 1. So this is your tangential equation. We did this 1,000 times. So first thing, when x equals 1, I'm going to find my y. 1 squared plus 1 is 1 plus 1, which is 2. All right, therefore, my point of contact is 1, 2. All right, pretty easy. All right, so this is my a. This is my f of a. We need to find f prime a, so we take the derivative, and we're going to plug in. So f prime a is 2 times 1, which is 2. That is my f prime a. Right? Type it into my equation. 2 times x minus 1 plus 2. Distribute the 2. 2x minus 2 plus 2. Y equals 2x is my answer. We got y equals 2x from a couple things. So, last one, show that the tangent line passes through the origin. Well, at the origin, what's our x value at the origin? 0. So when x equals 0, y equals 2 times 0, which is 0. So that's point 0, 0. And 0, 0 is the origin. So the tangent does indeed pass through the origin. Right? All right. There we go. How long have we been going here for? Hour 15. Ooh. I didn't think this would be too long. Here comes the good ones. Calculator time. Example 2. Consider the curve. Y equals x cubed plus minus 4x squared plus 16x plus 8. Find the equation of the tangent to this curve at point where x equals 0. So first thing, solve it like a normal problem. So we're going to find the equation of the tangent to this curve when x equals 0. All right, this is interesting. So when x equals 0, what does y equal? Plug in your 0 for that, and you get y equals 8. The point of contact, therefore, is 0, 8. All right, not bad, not bad. Just like we did before, still easy. Derivative. 3x squared, negative 4 times 2x, negative 6 times 1 is 3x squared minus 8x minus 6. So when x is 0, 3 times 0 squared, 8 times 0 minus 6 is negative 6. All right, so we got a bunch of good things here, right? What do we got working for us here? We're going to be using our tangent to the equation line. So let's see what we got. We got it right. We got our f of a. And we got our f prime. Plug them in. Here we go. Negative 6, x minus 0 plus 8. Negative 6x plus 8 is our tangent equation. Same exact thing we just did. Okay? Any questions yet on this? Now, we're going to do something different here. Here's the key. If we use technology here, we can actually find this equation. We did this earlier. Okay? Now, what we did earlier was we hit y equals right here. Boom. After you hit y equals right here, you type in your equation. So I'm going to clear this one. X caret 3. You have to hit to the right, or else you're stuck in 3. Minus 4x squared minus 6x plus 8. All right, so I entered my equation. I hit the word enter, and I graph it. Uh-oh, what did I do wrong here? Oh, I forgot about my cubed. I forgot my cubed. I had to put it back there. All right, so I'm gonna go to the right, and enter it. Hit graph again, and I get a graph that looks kind of like this. It's not totally great, so I'm going to go to zoom. Which one's a good one? Zoom box? Nope, not that one. I'm just gonna go to the window. My X's seem good. My Y minimum, I'll make like 25. I don't know. Let's see if that works. Enter. I just want to be able to see my graph. Okay, I can see the top. All right, that's not a bad graph. So I got my graph there. All right, now I want to draw a tangent when x equals 0. So now I hit second. I hit program. Right here, I go down to tangent, which is 5. I hit enter. All right, now I want it when x equals 0. So I type in the number 0. Notice it says x equals 0 here. Enter, and watch what this does. Boom, it just drew my tangent line. All right, when it drew my tangent line, it says x, and my tangent line is y equals pretty much negative 6x plus 8. Guess what? Where are you at? Negative 6x plus 8. That's my answer right there. So you can use the calculator to do this. I prefer to not use the calculator, but the calculator can be checked. Now, this says at what point does the tangent meet the curve again? So this is the part where you're going to need to use your calculator. All right, so we're going to use our technology. what we're going to do is we're going to type in y, type in the equation, and then press second trace calc, blah, 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 blah. So we're going to type y again. Oh, clear this out. Get that out. Type y. All right, so I got my first equation. Second equation was negative. Make sure you use the negative sign and not the minus sign. 6x plus 8. All right? Enter. Graph. So now you're just going to see the tangent line I graphed just turns red because I just typed that graph in. In order to find out where the point meets, you have to type in second. You're going to hit trace. So that brings you to the calculate. So second, light blue, trace, which is right here. Go down to number 5, which says intersect. Hit enter. You want the two graphs, so just move over here somewhere. So I got the blue graph, enter. Got the red graph, enter. Go close to where you want to be intersecting, so we're somewhere around down there. Hit enter, and look what it shows you. X equals 4, y equals negative 16. So, as you see here, x equals, oh, you can't see my laser on the board. X equals 4, y equals negative 16. That's my point. 4, negative 16. All right, so we had the original point, which was 0, 8, and my new point, 4, negative 16. All right, if you get 0, 8, it just means you did this point by accident. Do it again, but make sure your tracing's right around that point. And that's all there is to it. Boom. Remember, press y equals, enter in your first equation, enter in your second equation, and then we're going to trace it. All right, this is all how you do the checking of your answers. And then the tracing part, make sure you just enter them both in. Okay, you're going to second, trace, calculate, and then intersect. So, let's go do a problem on your own, which is problem number 9. All right, we're just going to use the calculator for the second trace intercept part. So let's go. We got, how many of these? We got 5 of these. All right, so just like we did before, we're just adding an extra step. All right. So find the equation of the tangent at the given point. F of negative 1, 2 times negative 1 cubed, minus 5 times negative 1 minus 1. So we have our x, we need our y, right? We have our a, we need our f of a. 2 times negative 1 is negative 2, plus 5 minus 1. That gives you 4. Let's give us 4. That gives you minus 2. How did I mess this up? Negative 2 minus plus 5 is negative 3. Minus 1 should be negative 4, maybe? That should be 4. We'll see this. We'll see how this turns out. All right, so the point of contact is negative 1, 4. All right, continue on. X equals negative 1. 2x cubed minus 5x plus 1. Oh, this should say plus 1. Boom, boom, boom. 6 minus 2 is 4. It says plus 1 in your packet. All right. Point of contact is indeed negative 1, 4. Next thing you're gonna do, you got our A. Same thing as you've been doing. We have our f of a. You need your f prime a. Derive the equation. 2 times 3x squared minus 5 times 1 plus 0. 6x squared minus 5. Now we need to know f of a, so we're going to type in the negative 1. F prime of negative 1 equals 6 times negative 1 squared. 6 times 1 is 6 minus 5. 6 minus 5 is 1. And 1 is my f prime a. We're going to use the tangent to find the equation. I just put it up in the top corner just to make it easier. So what you're going to do here is you're going to take 1 times x minus negative 1 plus 4. All right? Negative 1. 1 times x plus 1 plus 4. 1 plus 4 is 5. Y equals x plus 5. Right? Use technology. Fix your problem. Finish your problem. So the way you use technology, pretty simple. Enter both equations in your calculator. So I have my equations. I have my calculator. I hit y equals. I'm going to hit the clear button. I'm going to go down to y2. Hit the clear button. My original equation, 2x caret 3 to the right minus 5x plus 1. Press down. My new equation is x plus 5. That's my tangent equation. Enter. Graph. When I graph this, all right, not the best zoom, but it's good enough. Okay, now the point where I saw negative 1, 4 is this point right here. So I want to see where this point intercepts. So I hit second, trace, go down to number 5, enter, that's both lines, and I go to the right. So I'm closer to that point, hit enter. It says 0.27. 27 is my answer. All right. B. Keep going. All right, way to do problem B. Find the equation. So the first thing you can do, once again, same stuff as always. We have our x, we need our y value. You're going to plug it in. You could rewrite this equation for when you derive it later. X squared plus 3x to the negative 1 plus 2. Now when x is 3 squared is 9 plus 3 divided by 3 plus 2. 9 plus 1 plus 2 is 10 plus 2, which is 12. My point of contact, therefore, is 312. All right? So that means this is A. This is f of A. All right? Next thing you're going to do. Derive. This is the easier one to derive. 2x plus 3 times negative x to the negative 2 plus 0. So it's just 2x minus 3x squared. All right? We want to know f prime of a, so we're going to have to type in 3 into the equation. You could rewrite this by just pulling this to the bottom. So when x is 3, you get 2 times 3 minus 3 over 3 squared. 6 minus 3 ninths. 3 ninths, 3 over 9 equals 1/3. 6 minus 1/3 equals, 17 over 3. 6 is the same as 18 over 3. 18 minus 1, 17 over 3. Woo! That is my f prime a. Type 3 into the equation. Tangent has this equation. 17 over 3 times x minus 3, which is my a. 17 over 3, x minus 3, plus 12. Distribute. 17 over 3x. 17 times 3 is 51 over 3, which is negative 17, plus 12. 17 minus 12 is negative 5. Y equals 17 over 3x minus 5. Right? Good? All right. Calculator time. Calculator right here. Y equals, clear. Enter the first equation in, x squared plus 3 divided by x plus 2. Enter. Second equation, 17. Now this one, you're going to put 17x divided by 3 because you want the x on top. Minus 5. Enter. All right. You're going to hit graph. Whoa, that's a weird graph. Is that what I got over here? Yep. Notice it hits 2 different curves. That's good. We have the curve, what's our 1 point? 3 over 12 up. So we already have this point. So we want to know where that point is. So we hit second. Trace down to 5. Enter. We are going to go with this blue. Where are we at? The red. And we don't want that blue. We want this blue. Enter. Enter. Brings us right down to here. Gives us our points. Negative 0.305. Negative 673. All right. So that gives us our points. And using technology, about negative 1/3. Negative 6.89. Wait a second. How is that different than what I got? Oh, I messed up. Look at this. I put plus 3. This should have been plus 2. 2. Enter. Enter. Graph. All right, I made a boo-boo. My graph looks different. That's why my numbers were different. All right. Come on, hit. Second trace. Always check your answers. Intersect. All right, intersect that one with that one over there. Now my answers look good. Negative 333, negative 6.9. All right, all because I messed up one simple 3. Good. See. All right. F of 1.5, I take the 1.5 and I'm going to plug it into the original equation. 1.5 cubed plus 5 is approximately 8 and 3/8. All right. My point of contact is 1.5, which is A, 8 and 3/8, which is F and A. All right. Next thing I do, I derive this equation. 3x squared plus 0, which is 3x squared. I'm going to plug my A in to get f prime A. 3 times 1.5 squared gives me 3 times 2 1/4, which is 6.75. This right here is my f prime A. I'm going to have the tangent as the equation. 6.75 times x minus 1.5 plus 8 and 3/8. Distribute. 6.75 times x plus, minus 10 1/8 plus 8 and 3/8. Add these numbers together. You get 6 3/4 x minus 1 3/4. Right, so that's your tangent. The point where the tangent hits the other point. Once again, let's just get this calculator going. And I like to keep on showing you just because it's better. Y equals clear. Enter the first equation in. X caret 3 to the right plus 5. Enter. And then we get, what do we got? 6.75. You can enter in decimals. X minus 1.75. Boom. Graph. You have to hit the word graph. All right, that's pretty cool looking graph. Let's see. Hits it twice, good. We have it already hitting at this point right here, which is 1.5, that, because we know it's positive, so we have to see around there. Second calc, intersect. That graph and that graph, and I'm just gonna move closer to this point, hit enter, and I get about 3, negative 3, negative 22. Negative 3, negative 22. Boom, boom. Next one.